Hello, Internet. So today I wanted to talk about how to implement gotos in WebAssembly. So the thing about gotos is that in more traditional assembly architectures, you're able to put a label and you can have jump instructions basically anywhere that jump to those labels. But in WebAssembly, you don't have that. Basically, you have two constructs, right? You have the block, where if you branch from a block, you go to the end. Essentially, it's like breaking out of a loop in C. Or is a loop where when you branch, you go to the top, right? So yeah, so like going through a simple example of how it works, you see the instructions lined up on the right side. Right, so you have block and loop, right? So like when you have a while loop, you need to be able to go up, right? Go back at the end of the while loop to the top. The way that you achieve that is you create a loop block, and then you have a branch instruction that will take you to the top of the loop. Alternatively, like when you're in test after you've tested your condition, you want to be able to jump if your condition has failed, right? So you can test your condition here, and then you conditionally branch, and then when you branch from there, you have the blocks construct here, kind of wrapping the whole thing, and then you exit the entire block. Now, like gotos by themselves actually are not so bad to model, right? If you, like the problem actually arises when you interact when they start interacting with other things, but by themselves, conceptually, this is all you really need to do. When you do a goto that jumps forward, it's essentially the same thing as wrapping the thing you need to jump into in a while loop, and then the goto is kind of like the break. You're breaking out of that while loop, and then as long as the end of your while loop matches where the label is, you've got your goto, right? And you have the other thing as well. If you need to have a goto that jumps to somewhere earlier in the code, then really what you have is a continue, right? As long as the start of your while loop matches the start of the start loop. But yeah, so you might actually be asking, like, sure, you could, in those simple examples, you could use a while loop to kind of basically jump the way that a goto could. But like, aren't there like a whole bunch of crazy ways that you can like combine gotos that make it basically impossible to do that? And the answer is yes, right? So you have this sort of example where you have a goto B, where you have multiple places where you jump forward to a label B, and then you have a label A, and then you have a goto that jumps backwards to label A, right? Essentially, like if you try to directly map this code into the while analogy, you essentially need a situation where you need to break out of a loop that you have not started yet. And you need to continue back into a loop that you've already exited, right? Like this doesn't work, right, fundamentally. So how do you solve that, right? And there's another case where it's like, okay, it actually is possible to use this while loop trick, but you actually do need to rearrange a little bit, right? So if you think about it, like in this example, you have gotos that go forward, fine. There's only one label here, so you might think, oh, okay, I can have a while loop. But the problem is that the label is nested inside of another block, right? So you really have to jump across blocks from this if branch into the else branch, right? This turns out to be relatively common of a construct in C in real code. And yeah, like you have this impossible situation where like I need to somehow construct a while loop where like breaking out of the loop will get you to jump into a scope that opens inside your body but also needs to end outside of your body, right? Like that's not going to work. So for this case, this is what my compiler does. My compiler will detect, it has to be somewhat conservative about it, but it will detect that, okay, this is actually pretty safe to move around. And if it's safe to move around, I'll hoist it out so that the goto actually lands at a location that is outside the scope of, so that you really don't need to cross scopes when you do the jumps. Okay, so we talked about a couple things. Reducible but tricky, that's the example we just saw. Yeah, so we'll try best effort, but if that fails, I'll fall back to the irreducible case. In the irreducible case, you can still implement it using a giant while and switch loop, right? So essentially the idea kind of looks like this, right? This function is chunked up into pieces. You can see like the x equals 1 section here maps to case 4, x equals 2 section here, starting with label b, maps to section 3. So like the entire function is chopped up into pieces, and then each piece becomes a little segment under the switch. This approach essentially allows you to like implement any sort of goto. But the problem with this is that it's actually very inefficient. It kills performance and it bloats your code, and it's just honestly it's a little bit ugly. Okay, so like I think just to cover when we're on this topic, it's just kind of fun to cover Duff's device. But yeah, so the fun thing about Duff's device is that you have a switch statement where so you start with a switch statement, but you have a do while loop that kind of like intermingles with the switch cases in such a strange, in a bit of a strange way. So you think like, oh wow, is this even valid legal C? It turns out it is. It is legal C. The state machine actually can handle this as well. So if you try to compile this with Duff's device with my compiler, you get a giant state machine. While not the prettiest thing, it will still compile, and it will still it'll handle the code. As a part of this, I thought it was kind of interesting to be able to demo the way that the compiler will transform the code. So as you can, so I extended the disassembler to actually allow not fully compiling, but have the compiler just do some of the lowering passes that converts the code into a more WebAssembly friendly form, and like this one where we saw earlier. To make it easier to kind of visualize kind of what's happening. Yeah, and the code for this is available in the C compiler repository. But yeah, I hope that was interesting. I thought it was interesting. I don't know.